On January 9th, China launched its Long March 2C rockets. On board, the Einstein probe, which will survey space and hunt for X-rays emitted by explosions across the universe. A wide-field X-ray telescope will take broad scans of the sky, while a more sensitive telescope zones in on the details. That telescope was developed here at the Max Planck Institute of Extraterrestrial Physics in Munich, modeled after their eRosita telescope, which has been successfully operating in space since 2019.
We have expertise that we've developed over many years, over decades really, in building sensitive imaging and spectroscopic X-ray telescopes. eRosita is able to tell us the energy of the X-rays that we're seeing, and also very precisely the time at which the X-rays are received. It's very exciting. It's opening up a completely new discovery space for these kind of events.
Peter Friedrich is the scientist here responsible for the development of the mirror technology on the Einstein probe.
The Einstein probe is a Chinese satellite with European participation, weighing about 1.5 tons. One is a wide-angle telescope that can capture almost 10% of the sky at once. And in order to follow any changes captured, there is a second telescope, and so-called follow-up eRosita telescope, with which you can then take a closer look with a higher resolution.
This more sensitive telescope encompasses a mirror module with 54 nested mirrors through which the light passes, and on the other side, a special camera with X-ray sensitive detectors, known as CCDs, that are used to produce the images.
Here you can see the silver shiny part is a CCD chip. The image area, the memory area, the three smaller chips are the analog signal processors for reading out the signals from the X-ray photons.
In return for this technology, the European Space Agency will get access to 10% of the data generated by Einstein probe's observations. The satellite, shaped like a lotus flower in full bloom, was named after iconic German physicist Albert Einstein, for which black holes are the poster child. Einstein's theory of general relativity predicted the existence of black holes, where gravity's pull is so strong that nothing, not even light, can escape. It is hoped that during its 3 years collecting images some 600 kilometers above ground, the Einstein probe will allow Chinese and European scientists a better understanding of how these black holes really work.
Everybody very cooperative, very pragmatic, and I think we've been impressed by the expertise there in China.
This is their first collaboration, but talks are already underway between the Max Planck Institute and the Chinese Academy of Science for another, more ambitious project, also involving black holes. Watch this space. Natalie Carney for CGTN, Munich.